Hello and welcome back to the CCNA journey with me, Ryan. And in this section, we're going to continue with the networking fundamentals, reviewing duplex and speed. For those who don't know, you can contact me here on YouTube, connect with me on LinkedIn, Facebook or Twitter. And if these videos have been helpful, please do like and subscribe. Now, it's also worth noting that part of this video is being taken from the CCN and part of it has been re-recorded to the updated CCNA version. So let's get started. So what do we have to know about duplex? Well, first of all, so far throughout the course, we've talked about many things, and it's worth noting that duplex occurs at every single collision domain. And what do I mean by that? Well, in the last couple of videos, we've talked about switches, and in the CCN and previous videos that I've done, which I'll link in the description, I've also talked about things called hubs. And what's worth noting is every single collision domain. So let's say, for example, review from the last video, that we have a switch that connects to another switch that connects to a PC. Well, on this link, this segment here, this connection, whatever you want to call it, and then these two here, what would have to happen there is if they were Ethernet connectivity, which 90% of the time it is, duplex would need to occur. And duplex means that it will either be negotiated automatically. So this switch will talk to this switch and this switch will speak to that switch, and they would auto negotiate a duplex option, or it would be manually set. But either way, on every segment, whether that segment's to a PC, whether it's a connection between two PCs, let's say you've got an Ethernet rollover cable, or crossover cable even, and you connect them together, then again, auto negotiation will have to occur. So because of that, you're probably wondering, well, if it has to auto negotiate, what is it negotiating on? And the answer to that is there's two flavors. There's half duplex and there's full duplex. Now, half duplex is where you can send or receive, and full duplex is when you can send and receive. So obviously, most of the time, you would want send and receive. You certainly would not want send or receive. Now, send or receive is the half duplex, and this is the incorrect phase. The only time you'll see half duplex is if we're running hubs or very old bridges. And if you want to know more about hubs and bridges and the history of half and full duplex, then I'll link again a video in the description that goes back to the CCN where I talk about the LAN history. But because that's been taken out of the CCNA blueprint, we're going to be aware of the duplex and we're going to be focusing more on switch-to-switch connectivity, which is 99% of the time full duplex. And when I say 99% of the time, in fact, it's probably a lot less than that actually, because duplex is a common problem, still a common problem nowadays, especially when new services go live, okay? Because once it's negotiated and it's in production, you normally don't see duplex issues, but during the initial negotiation phase, you sometimes do. And the reason for that is mainly because the negotiation can be changed manually at the interface level. And if it's changed on the interface level, it can affect the other side. So what do I mean by that? Well, let's say, for example, that we've got a switch and we've installed another switch and we've connected them together using an Ethernet cable. Well, what's going to happen is both of these switches, like I said already, will send out the negotiation in attempt to negotiate, in an ideal world, full duplex. But the thing with negotiation is there are kind of two options when it comes to it. It's either on or it's off. And the reason it's important to know is that if this side here is turned off and the other side sends out the negotiation in attempt to negotiate a full duplex, well, if it doesn't get the response it wants, it doesn't know whether the other side is half duplex or full duplex. And the reason that's a problem is because the switch is primarily trying to ensure some level of communication. And what that means is that sometimes the switch or device will fall back to half duplex because one side is being manually set. So let's say the engineer installs this switch and the engineer, for whatever reason, has said, I'm going to manually set this interface to full duplex. Where the existing switch is on auto negotiate, well, it might end up that this side of the switch here actually has half duplex, which is the opposite of what we want. So normally in a production environment, you either have two options. You either manually set everything everywhere, or you set everything auto. Most of the time, and from my experience anyway, you tend to just manually set everything to avoid error, and that kind of makes sense. But what you'll also find is as these links speeds increase and newer technologies come out, the half duplex option sort of becomes less of a concern. So for example, if you statically set a gigabit port, so let's say these two ports up here were a gigabit, and you set one side to negotiate and the other side to manual, well, gigabit Ethernet does not fall back to half duplex. So that's something to keep in mind. Gigabit doesn't fall back to half duplex, but 100 megabits and lower will fall back to half duplex. So it's important to understand that, okay, what is duplex? Duplex is something that happens on a per interface level. It happens on every Ethernet segment because it's an Ethernet thing. And it can come in two flavors, half duplex, full duplex. And the difference between them is half is send or receive, and full is send and receive. The next point is common cause for slow speeds and no connections during installs. So I've put during installs, obviously it could be at any time, but from my experience, again, once the circuit is up and functional, you rarely see duplex issues with it unless an engineer has accidentally made changes they shouldn't have done, or thinking it's, wise to set one side as static and the other side not. So a good thing to keep in mind is if you have a new service that's just been installed and someone's reporting performance issues, i.e. slow speeds, go check the duplex, because if it's on half duplex, that's going to be a key indicator of a slow speed fault. And lastly, it tends to go in line with speed. So what do I mean by speed? Well, just now I mentioned that half duplex cannot fall back. Sorry, let me rephrase that. Gigabit connections cannot fall back to half duplex. So there's one comment regarding how it falls in line with speed. But more importantly, what it means is sometimes when people set the speed of a link, you have to set the duplex of the link. So we know, for example, switch ports, some of them can come in 1000 megabits per second, 1 gigabit, or 100 megabits per second, or 10 megabits per second. Well, in order to establish which speed to use, it negotiates with the far end. And we get into that a bit more later. But if you wanted to specifically set, let's say, the speed at 100, then sometimes it requires the duplex to also be set. Or when you set the duplex to full, it also requires you to set the speed. So they tend to go hand in hand with two settings, one are the same. And of course, in most scenarios, we want to ensure that we're aware of the maximum speed that the switch port can obtain and the correct duplex. What we're going to do now is we're going to jump onto some switches and we're going to look at what happens when you play with the duplex options. And these are actually two physical switches that we're going to log on to now and have a play with it. And then after that, we're going to jump into understanding a bit more about the speed. Two switches connected back to back. We have our switch on the left hand side, and we have what I've called the supplier switch on the right hand side. Down here, we can see the supplier switch is plugged into gigabit 024, and our switch is plugged in 1024. So what we're going to do is have a play around with the duplex and see the outcome of that. Now this particular switch here, if we were to look at the running config for a particular interface, the interface we're actually interested in, we can see that there's been one config that's worth mentioning, which is the speed has been manually set to 100 megabits per second. And the reason for that is because one, we're not talking about the speed at the moment, and two, so the supplier is actually a gig interface. So in order to have it perform as if it was 100 megabits per second, I had to cap the speed down. So you can see here, I've capped the speed to 100. And the reason for that is because if it's not capped to 100, it would obviously be a gig. And because it's a gig speed, it won't ever fall back to half duplex. In this scenario, I want to be able to produce the effect of having two fast Ethernet switches connected back to back. So let's say that our supplier, as I previously mentioned, these two guys are running the auto negotiation, and we can see the current status of the switch port by simply asking to show the interface that we're interested in at both sides. And this output gives us a lot of information, but really what I want us to focus on here is just this bit here where it says full duplex. We can say it's full duplex, so again that's send and receive at the same time. We can see the speed of the link, and same is true over here, 100 megabits and full duplex. Now again, like I said previously, you may not have access to both sides of the device. So let's say, for example, our supplier has decided not to run the auto negotiation, but instead manually configure the duplex in. So what they're going to do is put full duplex on the interface. So if we now look at the running config of the interface that we're interested in, what we're going to see now is duplex is full. You can see the port is now bounced, and our switch will try to negotiate with the supplier, but because it's unable to negotiate, because putting that full duplex on has turned off that negotiation, let's see what it's done to our port towards the supplier. You can see it's gone back to half duplex. And again, the reason it's done that is because it's 100 megabits per second. If this was a gig link and this was a gig interface and it supported the gig speeds, it wouldn't ever result back to a half duplex. So in order to fix this, we have two ways. We can either contact the supplier and ask them to go back to auto negotiation, or we can go under our interface and simply put the duplex back to full. Doing so will obviously bounce the port again, and then if we look at the interface configuration once again by doing the show interface and the interface we're interested in, we can see that the duplexing is back to normal. Just down here you're going to see a bunch of counters, but the things to keep in mind with these counters is if you have a duplex problem, you're more likely to see the collision counter and the late collision counter increment each time. So at the moment it's 0, and even though it was previously half duplex, there is no traffic actually traversing through the switch. But if there were, you would start to see collisions, and that would be an indication that the link itself is running an incorrect duplex. So again, thing to keep in mind is either you hard set it at both sides, or you agree to do the auto negotiation. If one side has set it as hard, then the other side cannot perform the auto negotiation, and depending on the speed of the interface will depend on the default behavior. On a 10 and 100 megabits per second interface, the default behavior is to fall back to half duplex. On a gigabit connection running a speed of 1000 megabits or 1 gig, it will always result to full duplex, never half. So moving on to speed very quickly, then we'll jump back to the Cisco's. It can find the correct speed even if auto negotiation is off. So again, like I said, it works a bit different to the duplexing. If the duplex is hard set on one side, then it turns off the auto negotiation, whereas the speed is a little bit different. If on one of the sides I've not set a speed, but on the other side I've set the speed to something that the devices can both handle, then it's able to still negotiate. And the reason for that is because, like I said, it uses this fast link pulses. It uses the physical attribute of the cabling and the electrical signals to determine the speed. Obviously, if I set my speed to 1 gig and the other side is only a fast Ethernet port, it will break. If I keep mine set to auto and the other side's a fast Ethernet port, then both will agree that fast Ethernet, which is 100 megabits per second, is acceptable. Now it can be used to limit speed, so if you've bought a particular service from a supplier, let's say you've bought a 100 meg lease line from them, and they've only given you 10 megabit per second bandwidth through that line, then sometimes instead of applying some sort of QoS or policing to save on configuration, they would set the actual speed on the physical interface to 10. So again, the only speed you can set it is 10, 100 and 1 gigabit per second or 1000 megabits, depending on obviously the speed of the interface. If a mismatch occurs, the link will go down. So if I set mine to 10 and you set yours to 100, the circuit will go down. If I set mine to 10 and you set yours to auto, then you should negotiate to 10. And the last point is some platforms you cannot set the duplex without first setting the speed. Okay, so here we are back in the switches. Let's have a look at the current configuration. So we look at the show running config for our switch. We can see that the duplex is set to full, but you notice that there's no speed command. That's because, again, like I said, the running config of a Cisco only shows the default. The default is for speed to be auto, therefore there are no speed commands on the interface. If we look at our supplier's interface, we can see the duplex is set to full. So then, now let's have a look at the speed. Now we know this is a gig link, so it supports up to 1000 megabits per second, but you can see it's actually reverted to 100 megabits per second because it's clever enough to know that the device on the other side, as in our switch, can only handle 100 megabits per second. If the supplier were to, for whatever reason, manually set theirs to 1 gig, what do you think will happen to our port? Well, the port will bounce, but notice it won't come back up, and our status will stay down. So something to put in consideration is if your device is only 100 megabits per second or only supports fast Ethernet, and your supplier is giving you a gigabit interface or a device which supports gigabit speeds, then you need to ensure that they actually set theirs to 100 megabits in order for it to negotiate correctly with you. Now what if our supplier has set the speed to 100 megabits per second, and again ours is set to auto? What do we expect to happen? Well, our interfaces come back up because it's clever enough to see what signals are coming down from the supplier and able to put the correct speeds on it. Well, what if the supplier has used the interface speed command to cap it to 10 megabits per second? Again, at first glance, the interface shows up. But now let's say we've put an order in with the supplier to increase the speed from 10 to 100 megabits per second. So what we're going to do on our side is we're going to preemptively set ours to the speed of 100. The supplier remains at 10. Now what do you think would happen? Both interfaces will go down and remain down because the speed between the two devices are currently mismatched. Okay, so that's all we've got time for in this lesson. So let's just wrap up what we've learned here as a whole. We went through two main topics, which is the duplex and the speed. We said that the duplex is how a device sends and receives traffic. So half duplex would only allow communication to be sent or received, whereas full duplex allows it in both directions at the same time, allowing traffic to be sent and received. We said the reason half duplex was around was because back in the days where everyone shared a collision domain, i.e. plugging into a hub, they all had to share the actual medium, and because of that the CCNA CD was very heavily used. Nowadays in our switch environment, each device that plugs off the back of it is inside their own collision domain and do not share the medium. As such, each device can send and receive with the confidence that there's less likely to be any collision or other devices sending traffic on the same medium. And because of this legacy, or evolution is a better term for it, within Ethernet, today we come across problems with duplex mismatch, where if the duplex is hard set on one side, it won't correctly negotiate with the device on the other side. So again, a few examples of that. If we have two devices plugged back to back, the default will depend on the platform,
but most of the time it's both sides to auto-negotiate, and they would auto-negotiate as full duplex. If one side is being hard set, the other side wouldn't be able to auto-negotiate and will revert back to the default, and the default will depend on the speed of the interface. If it's 10 and or 100 megabits per second, it would default to half duplex. If it's 1000 or 1 gig, it will revert always to full duplex. We then moved in to seeing some examples of that on the Cisco devices themselves and simulating some scenarios. After duplex, we moved on to speed. We said speed doesn't really use the same auto negotiation as what duplex does, but it still negotiates to some degree. We said again, the default for the platforms is auto, so they would both agree on the best speeds that each device can handle. In our scenario, we had a gig on one side and a fast Ethernet, which is 100, on the other side, and they both agreed on 100 megabits per second. When we changed the gig to 1000 megabits per second, the fast Ethernet device clearly couldn't handle that speed, and it was unable to interpret the electrical signals, and because of that, the device or the interface on both sides went down. We then had a look at what would happen if you mismatch the speed. If we had 10 on one side and 100 on the other side, and they were hard set, again it would result in the interface going down. If one side was auto and the other side was any speed which both sides agree upon, then they can both auto negotiate. And in order to achieve that, they use the fast link pulses, which is a physical attribute that's used to obtain the correct speed. I hope this video has been informative, and I'd like to thank you for viewing, and if it has been, please do like and subscribe.